Hello, good evening, and welcome to the another session of Parabola. In this session, we're going to solve some problems based on whatever we have discussed so far in the last 9 lectures. So let's see. So we have to find the area of the triangle formed by the pair of tangents drawn from -1, 2 to the parabola y square is equal to 8x and the chord of contact. So basically, I have a parabola here like this, and then we have a point here -1, 2. From here, tangents are being drawn to this parabola, and now this is the chord of contact. So we want to find out this area basically. So find the area of triangle formed by the pair of tangents drawn from this point. So this point is -1, 2. So that means area of this triangle. Okay, so this is R, P, and Q. So we know the area of triangle RPQ is equal to S1 to the power 3 over 2 upon 2A. We already have seen what is the area of the area of this triangle. So we'll need to find out S1 basically. So S1 is equal to Y1 square. So Y1 square is 4, and then a minus 8 into X1, which is -1. This turns out to be 12. So we'll be writing here 12 to the power 3 over 2 upon, we have 2A. So A, if I compare, then I have here Y square is equal to 8x. So 4A is equal to 8. So this implies A is equal to 2. So I just need to plug in here 4. So 12, 3 root 2 over 4 means you can write down here 12 root 12 over 4. This turns out to be root 12 can be written as 4 into 3, which is 2 root 3. So this turns out to be 6 root 3. So this is the area of triangle, okay, formed by the pair of tangents drawn from this point to the parabola and the chord of contact. Moving to the next. So we have to find the point of contact of the line kx plus y minus 4 is equal to 0 with the parabola y is equal to x minus x square. So here I have a parabola and I have a line here. So we need to find out the point of contact. That means if I consider this line kx plus y minus 4 is equal to 0 and I have y is equal to x minus x square. So if I solve this line and this parabola together for a common root, then I get my value of k, because this is going to be tangent for a 2-degree conic. So I can solve them for an equal solution. So from here, kx plus y minus 4 is equal to 0, and we have y is equal to x minus x square. So y is equal to 4 minus kx. This I can plug in here. So 4 minus kx is equal to x minus x square. This could be written as x square, and then minus k minus 1. I can take it common, yes, into x. And then plus 4 is equal to 0. So from here I'll solve for b square minus 4ac is equal to 0. So when I'm saying my line is tangent, that means it should have only one common solution. So b square minus 4ac is 0. So this turns out to be k minus 1 square minus 4 into 4 is equal to 0. So k plus 1 square is equal to 16. So from here we get k plus 1 is equal to 4 comma minus 4. That means k is equal to 3 comma minus 4 minus 1 minus 5. So this is the point of contact of this line. No, we have found basically k. So now if I just plug in here this k into this line, so I get y is equal to 4 minus k is what, 3 into x. So this is possible. Or I can have y is equal to 4 minus 3 into x is what, minus 5. So y is equal to 4 plus 15, which is 19. No, I think I wrote it wrong. 4 minus kx. So k is minus 5. So I can write down directly here y is equal to 4 plus 5x. So these are my two lines. And now to find the point of contact, I just need to solve them together. Or else, after finding this value, I can just plug in here directly. So I get my x. So calling the star equation, you can just plug in here. So 3a square. K is equal to x square minus, this is going to be 3 plus 1. which is 4x, and then plus 4 is equal to 0. That means I get x is equal to 2. So when x is 2, my y is going to be 2, 4 minus 6, which is minus 2. So 2 comma minus 2 is going to be the point of contact, or you can even plug in minus 5. So we need to see the point of contact, whether this is lying on the parabola or not. Because when I plug in x is equal to 2, so 2 minus 4, which is minus 2. So yes, this is a point on the parabola. Now one can test for even minus 5. So this turns out to be k square. K is minus 5. So again, I get minus 4x plus 4 only. That means this is the only point. So no need to worry. We can go ahead. Now moving to this. So if P is a point on the parabola y square is equal to 8x, such that abscissa of P is equal to the ordinate of P, then the equation of normal at point P. So I have my parabola y square is equal to 8x, which is here. And now they want the point at which abscissa of P is equal to the ordinate. So abscissa of P is equal to ordinate, that means x is equal to y. So if I consider any point on this parabola, this turns out to be x comma y. So here x is equal to y, abscissa is equal to ordinate. So when x is equal to y, I can solve for x square is equal to 8x. This gives me x is equal to 0 or x is equal to 8. So when I put x is equal to 0 here, I get y is equal to 0. 8 into 8, 64. So y is equal to 8 only I have to write down, because I cannot write minus 8 because abscissa is equal to the ordinate. That means the point here, either it could be 0 comma 0 or it could be point 8 comma 8. So I need to find out the normal at the point P. So one of the normal is the axis of parabola here. One of the normal is axis of parabola, which is x-axis. That means y is equal to 0 is one of the line. And this, for the second one, we have y is equal to x minus x square, 8x. We have y square is equal to 8x. So I can simply differentiate this. This gives me 2y. dy over dx is equal to 8. So from here I get dy over dx is equal to 4 over y. Now I want slope at the point dy over dx at 8 comma 8. So this gives me half. So this is the slope of the tangent. So therefore, slope of the normal would be minus 2. So equation of normal would be y minus y1 is equal to m into x minus x1. So I can add on y plus 2x, and this is plus 16. Now it comes on the left side, or you could consider transferring all of them. So minus 2x is 2x plus y minus 8 minus 16 is minus 24 is equal to 0. This is the equation of normal at point 8 comma 8 and also 0 comma 0. So we have two normals. Further, so if the normal to the parabola y square is equal to 4x at 1 comma 2, meet the parabola again at q, then find the coordinates of q. So for this, we can imagine the concept. This is my parabola, and so this is my point T1. So I know that if my normal drawn to the parabola meet the curve again at T2. So what is the relation? T2 is equal to minus 2 minus T2 is equal to minus T1. T2 is equal to minus T1 minus 2 by T1. This is the result which already we have proved, that if the normal intersects the curve again. So I can consider this point to be what, 1 comma 2. Now if I compare with y square is equal to 4x, then I get a is equal to 1. So point on the parabola is at square comma 2at1. I'll take first because I need to find out t2. So a is 1. That means I now have t1 square comma 2t1. So if I compare this point with 1 comma 2, so from here I'll be having t1 is equal to 1 only. So T1 is 1. That means I can get T2 is equal to minus 1 minus 2 by 1, which is minus 3. So T2 is equal to minus 3 basically. So therefore, coordinates of Q are A is 1. So t2 square, which is 9, comma, minus 6. So these are the other endpoints, like where my normal is going to meet the parabola again. Moving further, so we have x minus y plus k is normal to the parabola y square is equal to 16x. Then we want the value of k. So of course we have here y is equal to x plus k. This is my normal, and it's normal to the parabola y square is equal to 16x. So from here, if I compare, I get 4a is equal to 16, which means a is equal to 4. So equation of normal is, the equation of normal is y is equal to mx minus 2am minus am cube. So a is 4, and here I can see m is 1. So y is equal to x minus, this turns out to be, a is 4, so I get here 8 minus a is 1, so n is 1, so 8 minus 4. So I get y is equal to x minus 12. So I get y is equal to x minus 12, so that means these two are just same. So from here, if I compare, I get k is equal to minus 12. So on comparing with the normal. Now, moving to the next question. Okay, now if I look at this one, so we have number of points on this curve, from which two perpendicular tangents can be drawn to this parabola x square is equal to 4y. That means I have a parabola here, x square is equal to minus 4y, that means negative y is downward. So I'll be having this parabola. Now, two perpendicular tangents can be drawn to this parabola. That means the point must lie on the directrix of this parabola. So the directrix here is y is equal to 1. So that means I have to solve. So if I'm saying that I have to draw two perpendicular tangents, so that means that point must lie on the directrix. So if this point is lying on the directrix, that means I should solve the curve y is equal to mod of e power x minus 1 minus 2 and y is equal to 1 together. So solving them would give me the number of points. So that means basically I need to find the number of solutions of mod of e power x minus 1 minus 2 is equal to 1. So that means I'll be graphing this thing. So if I have to graph this guy, so just we'll go in a step by step. So if I draw e power x, then e power x would be here. It's my e power x. Now I want e to the power x minus 1. So I'll be just shifting this graph. I'll just be shifting. I cannot select it in fact. Okay. This graph I'll be shifting 1 unit below. So this graph will now pass through the origin like this, because when x is equal to 0, it is 1 minus 1, 0. So yes, this graph I got. Now this turns out to be e to the power x minus 1. Now I have to take its modulus. So when I take its modulus, the whatever portion that is below the x-axis will be mirrored along x-axis. That means I have this graph. So if I have this graph, then I will be, and also now I have to shift this graph 2 units below. So this graph when shifted 2 units below, okay, we'll go this way. We're removing this. So this graph when shifted 2 units below, we'll go this. Like this, and then like this. This is the graph shifted 2 units below. And now I need to take its modulus. So if I take its modulus, then again, whatever portion is below x-axis, that means starting from here, will be now flipped up. So I'm going to have a graph like this. Like this. So I'm going to have a graph this way. And this point would be x, y is equal to 1 basically. So this y is equal to 1 will serve as the asymptote to this curve. That means I have y is equal to 1 intersecting only at 2 points, this point and this point. Okay, so for more things, I'll just present the picture of the same diagram here. Yeah, so the graph would look somewhat like this. So we have drawn the same replica, in fact. And now you can see this is my line y equal to 1. So if I draw the line y equal to 1, they intersect at these 2 points. Also, this line y equal to 1 is asymptote to this graph. That means this graph and this line are not going to make any solution. So we have two solutions. That means there are 2 points on this curve from which two perpendicular tangents can be drawn to this parabola. So the answer would be 2. So moving to the next part. So let P be a point on the parabola y square is equal to 4ax. The normal to the parabola at P meets the x-axis at point Q. The area of triangle PFQ, where F is the focus and all blah 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 blah. The slope of okay, we'll see. So let's go ahead. That means you have a parabola y square is equal to 4ax like this, and P is a point on this. Say here this is my point P, and they're now saying the normal to the parabola P meets the x-axis at point Q. So the normal to this parabola meets the x-axis at point Q, and the area of the triangle FQ. So F is going to be the focus here. Okay. So F is going to be the focus. Now what is next? The normal here. Yes, this is point F. Now what they have given? If the slope m of the normal and a are both positive integers, then pair a comma m is what? All right. So that means we have the standard parabola y square is equal to 4ax, and we want to find out the area of this triangle PFQ. So for that, we know the equation of normal. So equation of normal at P having slope m. So equation of the normal at P having slope m is y is equal to mx minus 2am minus am cube. This is the equation of normal. And now they are saying that it meets the x-axis at point Q. So when it meets x-axis at point Q, so it meets x-axis at point Q. So this implies also we need to write down the focus here. So focus is a comma 0. Q I'll be getting from here. I need to get the point P. So point P will look like 8t square comma 280. 80 square comma 280. So if I write my normal in terms of t, then I know that t is equal to, if you see the equation of normal, so y is equal to tx plus 2am plus am, 80q. That means t is equal to minus m. So I'm going to have here am square comma minus 2am. So this is my norm. This is my point P minus 2am. And now to get point Q in terms of m, I'm going to have it here. So let's plug in y is equal to 0. So when I plug in y is equal to 0, this gives me 0 is equal to mx minus 2am minus am cube. So from here I need to get x. So x will become this m gets cancelled because m is not 0, because that's the only normal. So it won't form a triangle. Because if I take the point P to be 0, comma 0, so already they have mentioned that A is 0, comma A is positive, so I have this parabola. So X is going to be transfer this one to that side. So this gives me 2A mx is equal to 2am plus am cubed. So I can get m cancelled. So I'm going to have 2a plus am. That means a into m plus 2 is my x coordinate. So area of triangle. So area of triangle PFQ is equal to half of. Now I have all the coordinates, so I'm just going to plug in here. So the coordinates are basically, so we're going to write it here. This turns out to be, this is a into m plus 2 here. And second point is 0. And then also f is going to be what here. This is a, this is 0. And this point is am square, comma, minus 2am. And here it is 1, 1, 1. this area, this turns out to be exactly 120. That means from here, I'm going to have here this determinant I'm going to open. So let us open this determinant. So this turns out to be, if I expand it from the first row, I'm going to have a tough time, in fact. So expanding from this along this column would be better. So if I expand it, or else even if you do from this one, no problem, it's ultimately going to be the same. So this is 0 into this and then 0. So this is gone. So we can now write it. That means I'm going to have here a into m plus 2 into, this is 0 minus minus m means minus, that means 2am. This one done plus 1 into minus 2am, and then this is going to be 0. So this is minus basically. So I have to write it. I have to write minus here. So let's write minus, and then 2a square m is equal to 120 into 2 is going to be 240. So this could be plus also, this could be minus also. So I have to solve for plus minus 240 basically. So if I solve this guy together right here, so I'm going to have 2a, that means 2a square m square, and then plus 2 into 2, 4a square m. 4, I just have multiplied this one here. So 4a square m, and here this is 2a square m. That means I'm going to have here plus 2. So plus 2a square m. So plus 2a square m is equal to plus minus 240. And now since a and m are given to be positive integers, that means there is no point of having minus here. So I need to only solve for plus 240 as a and m are positive. So that means now I have to solve for a square m square plus a square into m is equal to 120. We can even take a square common, so I get m square plus m is equal to 120. Now one can just verify which option will satisfy this. So if I consider the first option, that's a comma m. So if I write down here 4, so 4 into m square plus m, we can see here, this is going to be 9 plus 3, 12. So 12 into 4 I'm going to have here, which is not 120, so A is not correct. And now we can see here 1 comma 3, so a square, this is also not correct because, and let's see 2 here. So 4 square plus 4, 16 plus 4 is 20, into 4 is 80, no. 3 comma 4 we can see. So this is 4 square plus 4, 16 plus 4 is 20, into 9. Wait, I think there is some error here. Yeah, so this point is basically m square. We have cancelled this m here. So this m square pending here. That means this is 2a plus m square. So m square would be here, and m square would be here, m square would be here. And this would be m cube now. So m cube here, now we can take. Just need to plug in all the values. Or else, wait a moment. We can take a square outside, and then m cube plus m is equal to 120. Now it will be better. So let's see again the options. So m cube is a square is 4 into 3 square cube. 27 plus 3 is 30, into 4 is 120. That makes our option A correct. Move to the next question. So we have PQ be the focal chord of the parabola y square is equal to 4ax. The tangent to the parabola at P and Q meet at a point lying on the line y equal to 2x plus a. That means this is my parabola y square is equal to 4ax, and then the tangents at P and Q. So PQ is the focal chord. That means this is the focal chord here. So this is P here and Q. So we know that tangents at end points of the focal chord are mutually perpendicular, and they intersect on the directrix here. So it's going to be like this. And now they're saying that this point lies on the line. There's some line here, which is y is equal to 2x plus a. So that means we need to get the point of intersection. So say point P is basically t1 square comma 2a t1. So this point would be a by t1 square comma minus 2a by t1. We know that the endpoints of the focal chord property. Now from here, the point of intersection. So the point of intersection would be a times, this is going to be t1 comma t2, a t1 comma t2, then a times t1 plus t2. Yes, now this point, now it is written that this point lies on the line. So lies on the line, and also t1 into t2 is -1 because it is the focal chord. So the point of intersection is going to be minus a comma a times t1 plus t2 is going to be -1 upon t1. So I can write down directly -1 upon t1. So there is no point of writing t1 now. It can be simply written as just t. So this lies on this line, y is equal to 2x plus a. So we can now just plug in this point on the line. So if I plug in this point on the line, so I'm going to have y is basically a into t minus 1 over t is equal to 2 into x is what? Minus a plus a. So from here I get, and the a is given to be positive. So that means I can cancel out this a from everywhere. So I get t minus 1 upon t is equal to 1 minus 2, which is -1. So t minus 1 over t is what basically -1. Now I want the length of the chord PQ. So length of the chord is, so length of focal chord PQ is a into t plus 1 by t square. This is what we have proved already. So a into t plus 1 by t square can be written as t square plus 1 by t square plus 2. So now if I square this expression, so I'm going to have t square plus 1 over t square minus 2 is equal to 1. So from here I get t square plus 1 upon t square is equal to 3. So 3 plus 2, which will turn out to be 5a, which will make option B correct. Now, next question. So PQ with the focal chord of the parabola y square is equal to 4ax, and then tangents at point P and Q meet in the, okay, this is the same question basically. It's the continuation of the same question, except for this part. So the entire story remains same. Only what we are going to discuss new is, this is my PQ. So point P I know. For point P we have here, wait, we're not going to find out the point of contact. Let's see what we can do. PQ subtends an angle theta at the vertex. So that means I have this point. So it subtends theta at the vertex. That means this point is angle theta. So this point is 0, comma 0. So I want to find out tan of this angle. So we need to get the angle between these two lines. So I think here concept of homogenization can be used, because this is basically what line, and this is chord, focal chord, or I can say chord of contact basically. So the chord of contact I can write down, but no, I won't be having this thing. Focal chord equation also I don't have. Okay, let's see what we can do. Best part would be to take a point here better, because now we have no choice here. So I can write down here a t square comma 280, and I know this is the other end of the point, so I can add on here a over t square comma minus 2 by t. That's the best thing that we can do. Now we want the angle between this, so I can add on here point O, and this is P, and this is Q. So I want the slope of this angle between them, so I can use tan theta. So tan theta is basically the angle between these two lines, say OP and OQ. So tan theta is going to be MOP minus MOQ over 1 plus MOP into MOQ I can use. So the slope of OP is going to be what? Just we can add on here. MOP is going to be 280 over AT square, which is 2 over T. So we get this. Now also we can find out MOQ. So MOQ is minus 2 over T and over 0 over A over T square. So from here I get minus 2t by a. So we get both of them. Now what we can do is just we can plug in into the given equation. Yes. And from this, can we have some information? I feel no. We cannot have any information here. Yeah. Therefore, tan theta would be is equal to, let's plug in all the values. So MOP is 2 by T and minus MOQ. MOQ is going to be 2T by A. No, this is A here. So A also gets cancelled. So just simply minus 2T. So this will turn out to be plus 2T over 1 plus MOQ is minus 2T into this point is 2 by T. So this would be simply, we can take 2 common and I get here T plus 1 by T. And in the denominator, this Tt gets cancelled. I get 1 minus 4, which is 3. So 2 over 3 would be out completely. 2 over 3 would be out. And now we need T plus 1 over T. So T plus 1 over T would be written as what? Because we have T minus 1 over T. So T minus 1 over T square minus, no, this is going to be T square plus 1 over T square. And then if I just simply add 4, I'm going to get the same thing. So I'll add 4 here. So 4 minus 2 will be plus 2. Yes. So T minus 1 over T square is basically what? Minus 1. So we have seen here. T minus 1 over T square is minus 1. So I can just write down 4 plus 1, 5. So this is going to be root 5 here. So all I need to know is just, I need to plug in here. So since we want the acute angle, this is 2 over 3 and then here root 5. 2 over 3 root 5 is given here. Okay. And now since A is positive, wait a moment, this is single correct answer. What would be, because see, we have two options, 2 over 3 root 5 and minus 2 over 3 also root 5. So let us see what we can do. Now we see here, this is tan theta here. In the modulus, it's going to be 2 by 3 plus or minus root 5. But here, if you see the length of this PQ, so length of PQ is basically 5A, which is greater than or equal to the lattice rectum basically. That means this chord will subtend obtuse angle. So theta is obtuse. So if theta is obtuse, that means this angle is going to be negative. So my tan theta would be negative of minus 2 over 3 root 5. Come to the next one. So let this curve be the mirror image of this parabola with respect to the line x plus y is equal plus 4 is equal to 0. So we can imagine this way that I have my x square plus y square is equal to y square equal to 4x is a parabola, and x plus y is equal to 4 is a line like this somewhat, and I need to find out the mirror image. So what we will do, we'll just take a point on this parabola. Say x is, if I compare here, so I have y square is equal to 4x. So from here I get a is equal to 1. So the point here is going to be simply t square comma 2t. So now we will parameterize this point and find the image. So image of t square comma 2t in x plus y plus 4 is equal to 0 b, we'll assume it to be h comma k. So now let us find the image. So h minus t square by 1 is equal to k minus t square by 1 is equal to minus 2 times t square plus 2t plus 4 over 1 square plus 1 square, which is 2. So this 2 gets cancelled. So that means from here I'm going to have h minus t square is equal to minus t square minus 2t minus 4, and k minus t square is equal to k square minus 2tm basically. It's going to be 2t here. So we'll write 2t and here also 2t. That means I'll be having now k minus 2t is equal to minus of t square minus of 2t minus of 4. So this and this gets cancelled, and here t square and t square gets cancelled. So we get h is equal to minus 2t minus 4 and k is equal to minus t square minus 4. So now we need to eliminate t. So from here we can find out t and just plug in here. Now a and b are the intersection of the of c with the line y is equal to minus 5. So y is equal to -5 means k is equal to -5, but for that we need h. So we'll just plug in here basically. So from here, if I solve, then I'm going to have h plus 4 over -2 is equal to t. We can just directly plug in here. So k is equal to minus of t is h plus 4 over -2 square minus 4. Now we can write down here y is equal to minus of, this is going to be h is x plus 4 over -2 square minus 4. Now A and B are the point of intersection of C with the line y is equal to -5. So we can plug in y is equal to -5. So I'm going to have here minus of x plus 4 over -2 square minus 4 is equal to -5. That means from here I'm going to have x plus 4 over -2 square is equal to 4 minus 5 is -1. So this minus and that minus gets cancelled. So from here I'm going to have here x plus 4 square is equal to, this is going to be plus or minus 4. So this is going to be here, 2 square is 4. So from here I'm going to have x plus 4 is equal to 2 comma minus 2. So now we got x plus 4 is 2 comma minus 2. So when that means x is equal to, this is x plus 4 square is perfect. X plus 4 square is equal to, this is 4. So we've taken the square root, so plus minus 2, perfect. So x is equal to -2 and y is equal to -6. So x is equal to -2 and y is equal to -6. So when x is -2, your y is basically, y already they have given that y is equal to -5. And here also y is equal to -5. So if I get the distance between them, so it's simply -2 comma -5 and y is equal to -6 comma -5. So distance between these 2 points is nothing but 4. So the answer would be 4. Look at this. So we have the parabola here. Y square is equal to 8x. And let delta will be the area of triangle found by the points of its lattice rectum and the point P half comma half. So we need to just see the position of P. Basically, I guess this is the area of triangle formed by tangents at P. So P point must lie on the parabola. So y square is equal to 8x. That means y is 4 is equal to 8 into x is half. So yes, that means P is here. So P is here and the lattice rectum is here. So basically we have a triangle here. This is what it talks about. Endpoints of a lattice rectum, and then and we're drawing the parabola. We're drawing the tangents. And delta to be the area of the triangle formed by tangents at P and the endpoints of lattice rectum. So that means if I draw the tangents at this point, tangents at this point, and tangents at this endpoint, so I'm going to have another triangle here. So what do we want is the ratio of area of these two triangles. So this we have seen. So say this is my point P, A, B, and say this is my point R, S, and then this is the intersection say T. So we know that area of triangle ABP over area of triangle RTS is equal to 2. This we have seen by the property in the lecture number last class basically. You can see this basically, I think 100, yes. So I'm solving this problem using this result. That area of this triangle over this triangle turns out to be 2. So we have used this property to solve this problem. And we have one more. So let E be the parabola y square is equal to 8x. So that means I have a parabola here. So y square is equal to 8x. And P is my point -2 comma 4. So it is somewhere here. Wait a second. Let's draw the focus first. So we have y square is equal to 8x. So if I compare, then I get 4 is equal to 2. So from 4 is equal to 8. So A is equal to 2. So A is equal to 2 comma 0 is the focus. And this point is going to be right here. This is my directrix, which is x is equal to -2. So x is equal to -2, and then my point P is going to be like here, which is -2 comma 4. Now, what it is saying that From here we have drawn two tangents. So we know that it's going to be the directrix. So that means here tangents drawn from a point on the directrix are perpendicular. So I know that these two tangents are perpendicular. And then let F be the focus of it. So this is F here now. Uh, so EFQ. So this is F here. This is Q here. And this is Q dash here. Now let us see. So let E be the parabola. Perfect. P is my point here. Q and Q to merge on E on the parabola. Okay. PQ and PQ are tangents to E. Okay. PF be the focus of E. F is here. Now the triangle PFQ is a right angle triangle. So PFQ they are saying. So they are saying that PFQ is a right angle triangle. So let us see this thing. Uh, this is my point from where tangents are being drawn. Of course, now uh, if you have a look, then we have proved that this portion to this portion, this will subtend a right angle at the focus. The length of the line segment intercepted between the point of contact and the directrix subtends a right angle at the focus. Okay. So this option A is definitely correct. What? The length of the length intercepted between the point of contact between the point of contact and the directrix. It's basically the length intercepted, so length will be on the tangent. So length on the tangent intercepted between the point of contact and the directrix. And the directrix subtends a right angle at the focus. Subtends a right angle at the focus. So this makes our option A correct. Now they're talking about B. So the triangle Q dash is a right angle triangle. Yes, because the tangents are perpendicular. So this is a right angle triangle. So distance between P and F is 5 root 2. So this we need to find out. P and F you can directly see here. You can use distance formula. So this turns out to be, this is 2 comma 0. So 4 square plus 4 square. This will turn out to be 16 plus 16. This is 4 root 2. It's not 5 root 2. So this is incorrect. And F lies on the line joining Q and Q dash. So we know that these tangents here are perpendicular. So if I join Q and Q dash, okay, Q and Q dash. So basically they are asking that if F is collinear or not. So F is going to be collinear if we can prove that distance between Q and Q dash is same as distance between QF and FQ, which is nothing but the focal distance. So in parabola, this is also the property here. So yes, D is also correct. F lies in the line joining P, F, Q, and Q dash. They are collinear. Moving to the next one. So let L be a normal to the parabola y square equal to 4x. If it passes to the point 9, 6, then line L is given by. So y square is equal to 4x. We can assume the equation of normal to be y is equal to mx minus 2am minus am cube. And now this norm a is equal to 1. So I'm going to have y is equal to mx minus 2m minus m cube. Now this passes through the point. So this passes through the point. So this passes through the point 9 comma 6. So I can just plug it here. So 6 is equal to 9m minus 2m minus m cube. 9 comma 6, yes. Just plug in here. So I'm going to have 6 is equal to 9 minus 2, which is 7m minus m cube. So we need to solve this equation. That means I'm going to have here m cube minus 7m and plus 6 is equal to 0. So one can see that m is equal to 1 is one of the root. We can use synthetic division. So 6 plus 1, 7 minus 7 is 0. So m is equal to 1 is the root. So I can write here 1 0, minus 7, 6. So 1, 1, 1, 6, and then minus 6 here. This is 0. So I'm going to have a minus 1, m square plus m minus 6 is equal to 0. So m is equal to 1 and m is equal to, from here, if I solve these things, so I'm going to have m plus 3 and m minus 2 is equal to 0. So m is equal to minus 3 and m is equal to 2. These are my slopes. So I can just plug in one of them here. I mean, since this is more than one curve, so we need to see the normals. So y is equal to, if I plug in m is equal to 1, so I'm going to have here x minus, this is 2 minus 1. So y is equal to x minus 3. Then next is plug in m is equal to minus 3. So this gives me y is equal to minus 3x. And since m is minus 3, so this is minus 3 plus 6. And then minus 3 cube is going to be plus 27. 27 plus 6 is 34 basically. No, 33. So we have one more normal. Y is equal to minus 3x plus 33. Plus 33. And another one is m is equal to 2. So if I plug in y is equal to 2x minus, this is going to be 4 here, and minus 2q is 8. So y is equal to 2x minus 12. So now let us see. So it will make my option A correct. Y is equal to x minus 3, and then y equal to minus 3x plus 33 is also correct. And 15 is nowhere mentioned, and then this is y basically. So y is equal to 2x minus 12 will make our option D also correct. So that's all for today. We'll see you in the next video. Thank you so much.